Hi, this lesson is from page 351 in your student book. Your objective is you'll be able to use direct variation to solve problems. And the essential question is, how do I find the direct variation? How is the direct variation different than the slope? So when the ratio of two variable quantities is constant, their relationship is called a direct variation. Notice this is not like the slope. Slope was y minus y over x minus x. Here we're just comparing y to x, and that's our constant direct variation. All right, this graph shows the amount of money raised in a bike-a-thon. How much money is raised per mile? So you're trying to find if there's a direct variation between how many miles and how much money is raised. So you're going to compare putting the money or the y in the numerator and the miles in the x. So notice for the first one, if they've gone 6 miles, they've raised $45. So that we would create a ratio, and the ratio would be $45 for 6 miles. And if you figure that out per mile, that's $7.50 per mile. Let's try the next one and see if the next one's consistent. So $30 for 4 miles, that too is $7.50 per mile. So you would call that your direct variation because they're constant ratio between the y and the x. Trying the last one, $15 for 2 miles is also $7.50 per mile. So remember, you're not subtracting the y's over the x's. You're comparing each y to each x. I'm going to skip that one. Okay, 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. So if we wanted to make that be a ratio, right away you see the two values there. So you would say, if he descends 1,900 feet in 2 minutes, that's 950 feet per minute. After 5 minutes, he's descended 4,750 feet. What rate is he descending? Let's see if it's consistent. So set that up as a ratio. See if it's the same, and yes it is, so that's your direct variation. But the rate that he falls varies directly with the feet and the time. So however long he's descending, he would do 950 feet per minute, and then you'd be able to tell how many feet it's been. So number 1, you'll create a ratio comparing the y to the x. Then you'll simplify. And if the ratios are the same, it's called a direct variation. And then again, we'll just be considering that k. And in algebra, they always consider k as the direct variation. So here again, look at, you're going to look at the y and put the y in the numerator, 5 over 3. And create a ratio. Then looking again at this one, 10 over 6, and then you would reduce that to 5 over 3 as well. And so your constant is actually the ratio 5 over 3. This should have been reduced. All right, a direct variation, this is a good vocabulary word, make sure you write this part down, is a relationship in which the ratio of y to x is a constant k. This part you must put in your notes. We say that y varies directly with x. So watch how this works. Let me move this slightly. So this is the equation to find the direct variation. We compare our y compared to x. Now, you're also going to take that value k, the direct variation, and you're going to substitute it in to an equation that looks like y equals the direct variation times x. Notice how that works. Here we want to get the y alone, so we're going to multiply each side by x over 1. The x's cross out, so now we get y alone. But if we multiply this side times x, we need to multiply this side times x. So now you see how we get the equation y equals k times x. So first find the constant, that direct variation. Then they'll ask you in the homework today to rewrite it as y equals the constant times x. So when they ask you to leave your answer as an equation, this is what they're looking for. All right, looking here at the graph, you're going to create ratios from y to x, y to x, y to x. So let's just really quickly. Y to x, 8 to 4, the direct variation is 2. 6 to 3, the direct variation is 2. And 4 to 2, I'm just comparing the y's to the x's, looking at the graph here. So then you would take that constant that you found and substitute it in for k. And so the equation your answer book is looking for is y equals 2, your direct variation, times x. All right, if you're given a table, you do it the same way, comparing your y to your x. So 1 to 25, or 2 to 50, which is reduced to 1 to 25, 3 to 75, which again you can reduce 1 to 25. So notice this is your constant of variation, they call it, the constant of variation, and you'll just substitute that in for your equation. All right, again from a table, you'll take your y and compare it to the x. So 36 to 2 is your constant of variation. 52 to 4. Ooh, this time you got 13. And 68 to 6. So you get 11.3. So this one is not a direct variation because you had different answers each time. Remember comparing it y to x. All right, good way to just look at a graph and know instantly if it is a direct variation. It'll be a proportional linear equation, but it must pass through the origin. So you must have just y equals a number, your constant of variation, times x, and it must pass through the origin. Oops. So if it has something after the x, like a -1 or a +5 or a -4, then it's not passing through the origin. So you would say then it's not a direct variation, just looking at the graph. All right, a 3-year-old dog is often considered to be 21 years old. So we would say his age equals how old he's considered. So sometimes people say, oh, a dog is 7 years in people years is 21 in dog years. You've probably heard of that before. So you multiply the dog's age times 7. So 7 is what you would substitute for k. So then you'd create the equation y equals 7x. As you can see, we just substituted in the numbers from the word problem. Divide by 3, they cross each other out. Divide by 3, and that's how you get k equals 7. All right, direct variation is y to x. Slope is subtracting y minus y to x minus x. So 12 is to 4, 16 is to 6, and 20 is to 8. Please solve that one and bring that to class tomorrow. and see if you're finding the direct variation, the constant of variation, and we'll talk about that part tomorrow. And that's it. Have a good night.